Hey, Mr. Crocker here. So we're going to continue our talks about geometry today. Day one, we talked about points and segments, rays and lines. Okay. Day two, we talked about what happens when those things come together and make angles. Sometimes they make acute angles, sometimes they make right angles, sometimes they make obtuse angles. And then we talked a little bit about that straight angle, perfectly flat. Okay. And today we're going to talk about line relationships, not like dating relationships, not that kind of relationship, just relationships, how they relate to each other. Okay. So a parallel line, parallel lines are lines that are going the same direction and they stay the same distance apart. So they're just like perfectly spaced and they just do that forever. Okay. That's what parallel is. And again, you know how we turned the acute angles and we said still acute, still acute, still acute, right? Same thing with parallel lines. So if they're turned, but they're perfectly spaced, okay, still parallel. If they're going up and down, but they're that perfectly spaced same direction, they're still parallel, okay? Perpendicular. Perpendicular means that where they meet, they make 90-degree angles, right angles, okay? So a lot of the times you'll see it like this, the cross shape, right? Where you have 90-degree angle all the way around, okay? 4 90-degree angles. If they meet a little bit off kilter, okay, but they still make that perfect L, still perpendicular. It's important, still perpendicular, okay? Because we're not, when we measure that angle, we're not talking about which way it's pointed, we're just talking about how wide it's open. So 90 degrees is 90 degrees is 90 degrees, okay? Now, day one, when we talked about lines, we talked about how we only draw a piece of them. That arrow means it goes on forever, okay? So you might see something like this where they haven't actually crossed yet in the drawing, but we know that the idea of a line is that they go on forever, and we can see that when these two lines eventually do cross, they will make a right angle. And so that makes them perpendicular, okay? So all three of these show perpendicular lines. The thing that matters is that they create 90-degree angles, okay? Now, we've got parallel lines, which will never cross. They will never cross because they're going perfectly. It's hard to do with your hands, right? Because like that's not actually perfect. You got to be like super careful. Parallel, right? Perpendicular makes a 90-degree angle. If they meet and they make any other angle, okay? So like here, look, we've got acute angles and obtuse angles, right? Acute, acute, obtuse, obtuse. Those are intersecting, okay? So really it's just if they cross and they're not 90 degrees, we call all of it intersecting. The same thing here. This looks like it's almost perpendicular, but it's not. It's just, you know, it's like a 94-degree angle and a 86-degree angle, but it's intersecting, okay, because it's not perpendicular and it's not parallel. Same idea here. These two lines, okay, remember how we talked about how we can sort of project that when they are going to cross, they will make a certain angle? Well, I can look at these two lines and I can go, well, they're further apart here, right? And closer together here. So that means they're not parallel. Eventually these two lines will cross. And when they do cross, they're not going to make a right angle. They're going to like slowly do this thing, right? So they're just intersecting. They're intersecting lines. Okay, so those are our three categories. Parallel lines, perfectly spaced, same direction, never going to cross. Never. If we drew those lines for 100 miles in both directions, they're so perfectly spaced that they would never cross. Okay, perpendicular lines, they do cross and they make a 90-degree angle. That square, that L, that right angle. Intersecting, okay, they cross, but they don't make a 90-degree angle. It might be an acute angle, it might be an obtuse angle. They cross. Okay, so now I'm going to draw a bunch of lines. We're going to talk about what we see in the drawing. Okay, so we got that, that, that. Okay, that's a lot, right? It's really a lot. And I would go through here and I would label these all A, B, C, D, E, just naming. What are these things called? They're points, right? They're points. Those little dots are points. I, J, K, L, M, N, O, P. Okay. So I did that because now I can use those letters and I can tell you exactly which piece I'm talking about. Okay. So do we have anything in our drawing that looks parallel? I think we do. Okay, we might have two. So segment AH, right? This whole line, segment AH is parallel to what? It's parallel to this one, right? Like railroad tracks. Railroad tracks are parallel, and they have to be, or else they'd throw the train off. That would be real bad. Okay, if they got closer together or further apart, that would be a problem for the train. So those are parallel. Okay, let's just stay with AH. So we're staying right here. Does AH run perpendicular to something? Yeah, I think it does. Okay, I think it runs perpendicular to BL. Okay, because here's AH, here's BL. These to me look like right angles. Okay, so that's a perpendicular we still call it an intersection because it's a crossing, but it's a different thing than intersecting lines like we talked about. Okay, so where these two lines cross, they make right angles, so they are perpendicular. Okay, now segment AH, does it run intersecting to anything else? Yeah, well, a couple of things, right? We've got this. It crosses KD. Well, we probably don't like those initials, huh? Giovanni, you know what I'm talking about. Okay. AH, it intersects with KD. Since we went there, I like KD, and I don't think he did anything wrong. Sorry. Okay. So AH and KD. Okay. Those are intersecting. They cross, but they don't make a right angle. They're definitely not parallel. Okay. Let's one more quick set of examples. All right. Let's focus on this now. Well, you know what? Let's focus on KD. Because why not? Why not? Right? Okay, KD, is it parallel to anything? I think KD to me looks like it's parallel to RG. Okay, parallel with RG. Okay, is also parallel with Russell Westbrook, RW. Okay, so RG, and KD parallel. Okay, does it run perpendicular with anything? I don't think it does. I don't think it does because we would need a line coming this way that would meet it and make that perfect T. We don't have it. So there's nothing perpendicular to KD. Okay. Not even Russell Westbrook. Now, we do have some intersections. We have lots of intersections, right? KD intersects with IQ. KD intersects. That's not a real symbol, by the way. I just made that up. It should be the symbol. Okay. With IQ. Okay. So parallel, railroad tracks, perpendicular, perfect T, right angles, intersecting, everything else. Okay. If it crosses and it doesn't make a right angle, it's intersecting. Okay. Bye. Don't be a KD hater.